All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where we're going to continue today looking at the geometric concept of fractional distance, this time in 2 dimensions. So we need some points to start with. We need a point M, and that point is going to lie somewhere, and then we need a point O, right? And our goal is going to be to find point N, where point N is some fractional distance between points M and O. So we can just make up coordinates, right? It doesn't matter. M lies at -7, comma, -3. Point O lies at, I don't know, 6, comma, 10. Okay, so the very first thing we do is plot the points. Let's plot those points. Where are we at here? -7 on the x, comma, -3 on the y. So we go over to -7 on the x and down to -3 on the y and put a dot. Okay, and that dot is going to be point M. And those coordinates again are -7, comma, -3. Point O lies at 6, comma, 10. So go over to 6 on the x and zoom up to 10 on the y and just put a dot right there. 6, comma, 10. And this is point O, and it lies at 6, comma, 10. Okay, so let's pencil in the path. So here is the possible path. I'll just shade it in brown here. All right, you can think of this as the path along which this fractional distance will lay. And what we're looking for is point N, where point N is some fractional distance from M to O, right? So direction is important. We're going to start at point M, and we'll walk along this path some fractional distance to point N. Well, how far do we want it to be? So from point M, let's say we want to be 7/10 of the distance. Okay, I want to be 7/10 from point M to point O. How do I find that? Well, we have to take this and break it down by axis. All right, so first we have to find the fractional movement along the x-axis, and then we have to find the fractional movement along the y-axis, and that'll give us our coordinates, x and y. So it's like 2 one-dimensional fractional distance problems combined together. All right, so what does the math look like for this? Well, I might run out of space here, but the x piece of this, so x sub n, will be located by finding the absolute difference between x sub O and x sub M. Right, because we're taking the absolute difference, it doesn't so much matter which comes first here. So let's see. And once we find that absolute difference, we will multiply it by 7/10, and then we will add that product to x sub O, or x sub M, because we're going to go from M to O, x sub M. So that's like the complete algorithm for the movement in the x direction for point in. So let's just work it out. Let's plug in x sub o and x sub m and find out what we get. So here we're going to equal to, open parentheses, absolute value, x sub o would be 6 minus x sub m, which would be negative 7. So that's 6 minus negative 7. And we see there that we've got a double negative. That'll become positive. And again, that's going to be multiplied by 7/10 and added back to the x value for the m coordinate x value. Well, let's keep following the rabbit hole. Okay, so we have here 6 plus 7, which is 13. So the absolute value of 13 is 13. So we have now 13 times 7/10. Okay, and we can substitute back in our x coordinate for the m point, and that would be negative 7, so plus negative 7. All right, so what is 13 times 7? Well, I have no idea. Just multiply 13 times 7 and find out. 91. Okay, so now what I'm looking at is 91 tenths plus negative 7 minus 7. And before I write the 7, we need to find 7 in terms of 10, right? So that would be 70 tenths. So 91 tenths minus 70 tenths. Two different ways to write the fraction. 91 minus 70. All right, so now we're going to do 91 minus 70. And we will borrow. I didn't need to do that. So it's 1 minus 0 is 1, and 9 minus 7 is 2. Sorry about that. I'm not thinking clearly. So now I've got 21 over 10. So 21 tenths is the x coordinate of point in. So we can go up here to point in and put 21 tenths. And we'll turn that into a mixed fraction and estimate its position here in a moment. Now we have to find the y component of n, right? So we found half of the coordinates. Let's go back here and find the y component of n. So here's y sub n. And again, it's going to follow the same kind of algorithm. We have to take the absolute difference in the y coordinates. So y sub o minus y sub m, and make sure we get the absolute difference there. Multiply that absolute difference by 7/10. That's our fraction. Okay, and then whatever we get from that product, we will add it back to y sub m this time. All right, let's plug and play. So we'll plug in what y sub o is. That's 10. So equals, open parentheses, absolute value 10 minus, and then y sub m is negative 3. So 10 minus negative 3. Close that absolute value there, multiplied by 7/10, and added back to the m coordinate, the y sub m coordinate. So that would be negative 3. All right, so there's the problem we have to solve. And so that means we've got, let's see, 10 minus 3 is 10 plus 3. That's 13. And so here we are, 13 times 7/10. So even when you try hard to make these values different, I've come up with like the same problem. So we'll do that. 13 times 7, okay. And we're going to add that to negative 3. 13 times 7 is 91. tenths. And we're going to subtract out now 3. Well, we want 3 in terms of tenths, so we'll subtract out 30 tenths. Okay, so 91 minus 30. Let's try to do subtraction correctly this time. 91 minus 30 is 1 and 6, 61. So this is 61 tenths. And that is the y coordinate of the in position. Okay? Well, let's actually plot it. We want to plot it somehow. Well, we're going to have to estimate. I mean, this isn't a scientific grid here, but let's first turn these values into mixed numbers. So 10 goes into 21 twice with 1/10 as a remainder, so that would be like 2 and a tenth. So just a hair beyond 2. And where would 61 tenths be? Well, it'll go in 6 and a tenth. 6 and a tenth. So just a hair beyond 2 and just a hair above 6. And let's see if that falls somewhere on this line. I mean, if it doesn't, well then, my God, we've done it wrong. So let's go a hair past 2. It's going to be impossible to like estimate. And then a hair past 6. Let's see where we get with that. Sometimes I like to put in these little guidelines. Okay, so a hair past 6 and a hair past 2. There it is. So according to the math, point in should lay right there. Point in should lay right there at 21 tenths, 61 tenths, or 2 and a tenth, to be like 2.1, 6.1. Okay? So that is fractional distance in 2 dimensions. Now, guys, think about it. So whenever you're asked to find fractional distance, you've got to ask, well, where am I starting from? Because look, 7/10 of the distance along this line from M to O will put you at a different location than if you were traveling in the other direction. You would be somewhere down here, right? If you were traveling in the other direction. So imagine you're in a car driving on a road and you're going somewhere. So this is an important point, that the distance itself, which for each coordinate was different, but the distance itself is different than the location, right? And actually, I think the distance was the same here, right? Yeah, the distance was 91 tenths on both axes. But when you're traveling along that distance, the location of that coordinate will change based on whether you're starting here and going this way, or starting here and going this way. So that was fractional distance in 2 dimensions, right? And if this was confusing, we just need to practice more. I mean, because it's not like there's a cookbook for this. We're just kind of following the logic of what we need to do. So from a perspective of like how to teach this, practice, practice, practice. Make sure that you remember what you're doing, and make sure that the students are fully aware of which distance they're traveling, and just make sure that as you walk them through the math, they don't get overwhelmed in the arithmetic. Okay, well, that is fractional distance in 2 dimensions, and I think we might work another problem like that because they're interesting, but we'll stop for now.